Okay. So today, the next concept is what is polar plot? Polar plot. How to draw a polar plot? What is the concept behind polar plot? Okay. So polar plot is nothing but it is a plot. It is a plot drawn between magnitude, magnitude and phase of open loop transfer function when frequency is varied from 0 to infinite. Okay. So in electrical circuit analysis, maybe it is one or two, I'm not sure about it. There is a concept locus diagram. Okay, a locus diagram. In that locus diagram, for a RC series circuit or RL series circuit of, we are varying one parameter while keeping another parameter as constant. Okay, so if we keep one parameter constant and varying the other parameter, the phasor of the current phasor will vary in semicircle manner. You have seen in that subject. Similarly, here also a polar plot drawn between a magnitude versus phase when the frequency is varied from 0 to infinite. Okay, for example, to understand the important concept of a polar plot, I'm taking one open loop transfer function g of s h of s is equals to 1 by 1 plus s, for example. So this is the type 0 system. Okay. So in this for this open loop transfer function, I want to draw a polar plot. So to draw polar plot, we have to convert into frequency j omega. Just a substitute s equals to j omega. G of j omega h of j omega will be 1 by 1 plus j omega. Okay, we have to draw magnitude of this open loop transfer function and the phase of this open loop transfer function with respect to frequency. So for that, I am taking a magnitude m equals to nothing but mod of g of j omega h of j omega. That is nothing but, so here numerator is 1, then the magnitude will be 1 only. 1 divided by, in the denominator, 1 plus j omega, so the magnitude will be 1 plus omega square. Okay, and the phase angle pi will be nothing but a angle of open loop transfer function g of j omega h of j omega. So here numerator, the angle of numerator is 0 degrees and the denominator is tan inverse of omega. Okay, now if you simplify this one, you will get minus tan inverse of omega. Okay, so finally we got magnitude m equals to uh, 1 by under root 1 plus omega square, and phase angle pi equals to minus tan inverse of omega. So if you observe these two equations, magnitude equation and phase angle equation, each one are function of frequency omega. Okay, so while if you vary the value of frequency for a given system, then the magnitude will be vary, and also as well as phase also vary. So for that I am taking one a tabular form to to verify how the phase or magnitude and phase will vary with respect to frequency. So it is a frequency, and this is the magnitude value, and this is the phase angle value. Okay, so here I am taking a frequency value equals to 0. If omega equals to 0, then the magnitude value will be 1. If you substitute in this equation, then the magnitude value will be 1, and the phase angle will be 0 degrees. Okay, and next change the value of omega to 0.1. Okay, if omega equals to 0.1, then the magnitude value will be 1 plus 0.1 whole square under root 1. So it is 0.99, 0.99, and the magnitude will be tan inverse of minus tan inverse of 0.1. So it is minus 5.7 degree. Okay, so and I am changing the frequency from 0.1 to 0.1 to 0.5. Then the magnitude value will be 0.89, and the phase angle will be minus tan inverse of 0.5. It is minus 26. Okay, minus 26.56 degree. Again I am changing the frequency to 1. If omega equals to 1, then the magnitude value will be 0.707, and the angle will be minus 45. Okay, again I am changing the frequency 1.5, then the magnitude will be 0.55, 0.55, and the angle will be minus 56.30 degree. So and so on up to I am changing up to frequency equals to infinite. If omega equals to infinite, the magnitude value will be 0, and the phase angle will be minus 90 degrees. Okay, just observe this tabular form. Here I am changing the frequency from 0 to infinite, 0 to infinite. Okay, uh, so if you change the frequency value from 0 to infinite, the magnitude value decreases. Just observe that the value of magnitude from 1 to 0. Okay, and the phase angle also increases in anti-clock clockwise direction. The phase angle increases in clockwise direction. Okay, so for this from this tabular form, we have to draw a plot between a magnitude and phase angle. Okay, so just observe that how can draw a polar plot. So for that I am taking one a normal graph with a scaled one. Okay, just imagine. Okay, so first for omega equals to 0, the magnitude and phase angle will be 1 at an angle 0 degrees. Polar form, it is in polar form. So we can draw this polar form in this 4 quadrant axis at 0 degree axis. On the 0 degree axis we can write this is the 0 degree, and in anti-clockwise direction we can take it as positive. In clockwise direction we can take it as negative. Okay, so it is 0 degree with a magnitude with magnitude 1. So let it be, this is the magnitude, let it be, this is the magnitude 1 on 0 axis. Next polar form is 0.99 at an angle minus 5.7. So this polar form will be located in fourth quadrant with a magnitude 0.9, and it is approximately equal to 9 1, and the angle is minus 5.7, okay, in anti-clockwise direction. So then the graph will be like this. We have to draw a line with a minus 5.7 degree line. Let it be, this is the 5.7 degree line. On this line we have to take um, magnitude 0.99. So I'm considering it is, this is the magnitude with a 0.99. So this red color line, we got this red color line if omega equals to 0, and this blue color line we got it for omega equals to 0.1 radian per second. So similarly I am changing this frequency uh, 0.1 to 0.5, then the magnitude is 0.89, okay, 0.89, and the angle is minus 26.56. Let it be, the 26.56 line will be like this, just assume, okay, this is, and this is the magnitude 0.89. This line will be, this phasor is obtained when omega equals to 0.5 radians per second, okay. And similarly for omega equals to 1, the magnitude value is 0.77, and the angle is 45 degrees. So let it be, this is the 45 degrees. This is just approximate diagram, not exact diagram. Let it be, this is the 45 degrees in clockwise direction, okay. And the magnet, this is for omega equals to 1 radian per second, and the magnitude is here, this point, I'm considering this point is 0.77, 0.707. And for omega equals to infinite, and omega equals to infinite, the value of magnitude is 0. So 0 will be here, and the angle is minus 90. So this is the minus 90 degree line. On this line the magnitude should be here, okay. This is the phasor, just the magnitude is 0, nothing but a dot. Phasor is nothing but a dot. If you combine all these phasors, if you draw a tip of all the phasors like this, we will get a plot, we will get a plot like this, okay. This plot is known as a polar plot. So we don't consider all these phasors, just we write, we, I'm just removing all these things, okay. So this is the final plot. So this is the final plot. This plot obtained when frequency is varied from 0 to from 0 to infinite, okay. So the plot is moving from this point to in this direction, clockwise direction, okay, and reaches to 0 at omega equals to infinite. So this is a polar plot we can draw, okay. Thank you.